So here we are again with the graphs of trigonometric functions. In this case, it's turn for the cosine function. As you investigated, graphs of trigonometric functions, cosine functions, y is equal to x. As you probably already did your research that I asked you to do in advance, what changes from the graph of the sine function to the cosine function is that the cosine function is shifted pi over 2 units from the graph of sine. It's the same graph, but just in a different location in x. So it seems that the shape is a little bit different. If you notice the graph of the cosine function, as can be seen here, it's a U-shaped. The period is the same for the basic graph. The amplitude continues to be 1. The period is 2 pi, which is the same. The endpoints, since their coordinates are now at 0, 1, and at 2 pi, 1. The domain goes from 0 to 2 pi, and the range from -1 to 1. The average y value of the basic graph is y equals 0 because it's at the x-axis. So here we see, being this the average y value, this at the x-axis, then my amplitude is 1 above and 1 below the average y value. What changes is the shape of the graph. I am still splitting my graph in 4 parts. The thing is that the cosine function now begins at the highest point, which is this one. Then I split the first fourth, is where I cross the x-axis. Half the period, I reach the lowest point in the graph, and on the third fourth, I reach the middle point in the graph, and then at the end, I go to the highest point in the graph. Different, very different from the graph of the sine function. They're the same, they come from the same part, but they're different, okay? So what changes is the shape. The procedure is absolutely the same. I am still going to have an amplitude, which would be the coefficient of the cosine function, the b value, that is the denominator of the period. The b value in bx plus c in the equation is the denominator of the period. The c is the horizontal shift that the graph is going to be having, and d would be the vertical shift, meaning this part plus c and plus d. The endpoints, bx plus c equals 0, bx plus c equals 2 pi. I do it in the same way that I did the sine function. And this part of the bx plus c, remember that I get them directly from this part of the equation without having to change the signs. The signs don't change, please remember that. So now moving on to the examples. They're asking me to sketch the graph and determine the endpoints, the period, the amplitude, the average y value, the domain and the range in one full cycle of the graph of y is equal to 3 plus 2 cosine of x plus pi over 2. Let's remember from math 3 that this -3 can be written at the beginning or at the end of the function. It's exactly the same thing whether I have it at the beginning or at the end. This number over here is the one that corresponds to the plus d in the formula, but it is now written at the beginning. So in this particular case, in this particular example, the amplitude is going to be, the amplitude is 2. I remember that I obtained the amplitude from the coefficient of the function. In this case, it's cosine, so the amplitude is 2. The coefficient of the function, 2. The b value is obtained from the coefficient of x. Remember in this part that if I don't have a number as a coefficient, the number is 1. So it's a 1 that is not written here, and that is going to be exactly my value of b. So from the b, which is the denominator of the formula for the period, I plug it in, 2 pi over 1, and this is equal to 2 pi. The period of this graph is going to be 2 pi. The average y value, remember that the average y value is from the one that splits my graph in two, from where I count the amplitude. But in this case, my graph is shifted 3 units down to this, due to this value that is adding or subtracting from, adding to the function or subtracting from the function, whichever way you want to see it. This -3 here is telling me that the graph is going to be shifted down. Okay, and remember that this -3 here can be written at the beginning or at the end of the function. Actually, this can also be seen as y equals 2 cosine of x plus pi over 2 minus 3, and it's exactly the same expression. So this means that the graph is going to be shifted to the left due to the pi over 2, and that the graph is going to be shifted down to the -3. Amplitude 2, the value of b is 1. So my period is So my period is 2 pi right over here. I have my period is 2 pi. And I will explain when we get the average value of y is equal to -3 in a little while. Okay, let's go over to the endpoints. Bx plus c equals 0. Bx plus c is equal to 2 pi, which is like with the sine function. So I take that part from over here and solve for x. So for the first one, passing subtracting, x is equal to minus pi over 2. And for the next one, x plus pi over 2 is equal to 2 pi. Go subtracting, so my graph will end at negative pi over 2. Will begin at negative pi over 2 and will end at 3 pi over 2. This means that my period is of 2 pi's. Let's do this in the graph. Let's see how this translates to the graph. Okay, so I have a huge coordinate plane so that I can see what I am doing. And if I am to sketch this graph, remember that first I enclose my box according to the endpoints. I enclose my box according to the endpoints. My endpoints were negative pi over 2 and 3 pi over 2. So negative pi over 2 is right here. Remember that I have to start making my box. And the other part is 3 pi over 2. So that would be the x extension of my graph from negative pi over 2 to 3 pi over 2, which is going to be giving us also our domain. So I can state that my domain goes from negative pi over 2 to positive 3 pi over 2. Just by getting the endpoints with the formulas that we have been using since the beginning. So that will be my domain. My range, remember my average y value. Remember that this graph is shifted 3 units down from the original graph, and the original graph has the average y value at the x-axis. So from there, I have to go down 3 units, and I will be 1, 2, 3. So I am exactly right here. That is my average y value. Remember that from the average y value, I count the amplitude in order to enclose the box. So from the average y value, I go 2 units above it, being at y is equal to -1, and 2 units below it. And from there is from where I get my range. So my range goes from 1, 2, 3, 4, 5, from -5 to +1. My range is from -5 to -1. Okay, so I have all of this. Remember that I have to split my period I have to split my horizontal extension of the graph into 4 equal parts. So I am from pi over 2 to 3 pi over 2. So this is pi over 2, from negative pi over 2 to pi over 2 is the first half. And from pi over 2 to 3 pi over 2 is the other half. So remembering the basic graph of the cosine function, I have that the lowest point is at half the period. So in this case, this means that half the period is at pi over 2. This means that the lowest point in my graph is exactly here. Then I have to get the highest points of the graph. In this case are 2. Remember, the sine function only had one highest point. In this case are 2 highest points. So because the graph begins in the upper right corner on the upper left corner of the box and ends on the upper right corner of the box. So this is my first endpoint. Then I split this into halves. Remember, have the first, I have half the period, and that has to be split into halves. So this would be the other half. So according to the shape of the cosine function, this would be the first quarter, second quarter, third quarter, and the fourth quarter at the upper part of the graph. And this would be the final graph of this cosine function that I was looking for since the beginning of the problem. That would be the cosine function that I was discussing at the beginning of the problem. Okay, so I already have the amplitude, the period, the average y value that was -3 because the graph got shifted 3 units down. The domain from negative pi over 2 to 3 pi over 2, and the range from -5 to -1. I am missing to get the coordinates of the endpoints. Remember that what we get here are only the x values of these coordinates. So the endpoints of this one, the complete endpoints, the complete coordinate of the endpoints are going to be minus pi over 2 comma something and 3 pi over 2 comma something. That something is the y value. So minus pi over 2 is exactly at -1 in a height of -1, and the same thing with the other point. So the endpoints are minus pi over 2 comma -1 and 3 pi over 2 comma -1. And this would be our complete example. Sorry, the cable is right in the middle, I'm sorry. There we go.